I'm Alex. I'm the CTO and co-founder of Cortical, as was described. Cortical is an AI as a service platform. We use AI to build AI, automated machine learning. And effectively, that means we can cut the cost, risk, and time it takes to go from an idea to something that's actually building value in your company of an AI type. So we work across a whole bunch of industries. We work with clients like Deloitte, for whom we're automating their UK tax practice, which is actually going live today, so wish me luck. To finance, to companies like the NHS. But in the automotive space, we're very pleased to partner with a company called Quick Release. And with them, we're doing some really interesting stuff around warranty analytics and connected vehicle, amongst some other things. And I'm going to touch on that a little bit later. But firstly, what is the time right for AI now? Maybe also answering why is the kind of manufacturing industry slightly lagging behind some of the other industries we've looked at? So only 9% of digital or manufacturing companies currently, according to this PwC survey at least, only 9% are either doing AI in production or planning to do that this year. That's quite a small number, even by the industry average. And that's a number that's looking to increase to more than double in the next 5 years. But there's a pretty good reason why we're slightly behind in the manufacturing industry, and that's really just the degree to which things are digitized. Now, clearly with AI, you really need data as a prerequisite, and to have data, you need digitization. Obviously, with expensive bits of equipment, you might not want to replace that just to get a kind of digital version. And it's also kind of key that these bits of equipment are connected. It might be quite expensive or difficult to get the data out of certain machines if they're not implicitly connected. So you've only got 4%, you've still got 44% of companies that are actually in this space with a digital connected factory, but that might not necessarily be enough because it's not enough to collect the data. You have to actually have a kind of historic backlog sufficient to actually train a model. But this brings me to my first point, which is that it's often, we come across a lot of companies that believe they don't have enough data when they actually do. And the reason for that is it's extremely difficult to know if you have enough relevant data, unless you're an expert or at least knowledgeable in machine learning. And even then, until you've actually started working with that data, it's really hard to say. So for something like sales forecasting, you might need actually 3 years of like monthly data. But for something like predictive maintenance, it might be good enough to have 3 months of high fidelity sensor data, provided enough equipment failed. Another interesting point is that a lot of companies use ERP, MES, CRM, or equivalent kind of digital platforms. And often they don't realize quite how useful the data is in these platforms. And so that's actually data that's potentially not considered when people are looking for places to attack with AI POCs. And essentially, the cost of actually doing stuff in AI is just going down. And the reason for that is data scientists as a species are becoming less expensive to hire because there's more of them and everyone's getting into that field, which is great. Aside from the increase in data generally, it's also just cheaper to do AI projects based on the technology available. So technologies like ours and others, where you're basically reducing the time and the cost in terms of personnel to go actually get some decent results with machine learning. So I just wanted to kind of talk to some of the possibilities we've seen in manufacturing, and this is areas where we've done some work, so we feel confident in talking about. The first of which is warranty analytics, and this is really exciting because the cost of warranties in the OEM space, as most of you probably know, is extraordinarily high. The work we're doing on this at the moment is looking at, given the connected vehicle data, can we predict if a part's going to need to be replaced before it breaks? And we've had some really interesting initial results. I can't name too much at this point because we're still doing the POC, but we can predict parts that if they fail, it really requires an engine rebuild and requires a courtesy car, and it might take a while to order that part. So a huge cost if it fails, but the part itself is pretty cheap and it costs almost nothing to deliver it to the dealerships, as they essentially do deliveries daily anyway. So that's a fantastic and very interesting part of the space we're very excited about. But there's loads of other stuff. for example, ticket consolidation. So this is where you have potentially hundreds of test cars, they're all driving around. As they break, people will raise tickets. These tickets might be in English, in German, in all sorts of different languages, and contain very technical error codes. So it's a kind of complicated natural language problem. And currently what they have is very expensive engineers who are very bored having to sort of reconcile these duplicates. So we built an NLP machine learning solution on a platform which could basically, for any ticket, recommend very likely duplicates. So that basically takes the cost and time of dealing with this sort of data down massively. Then we'll talk about predictive maintenance in a bit more depth following this slide. Another interesting place we work is production capacity optimization. So in one particular instance, we were able to predict the demand for a various component twice as accurately as the customer was able to predict it. And this led to a much more efficient factory where we could have more machines running and hold less stock. And finally, smart logistics and optimizing that. Again, something else I'll go into a bit more depth on, but another very ubiquitous and highly profitable AI area to automate if it fits your industry. So this is a particular example where we worked with BT and their maintenance partner MBNL, and we essentially want to predict cell tower failures. This is for a number of reasons. Well, one, because it costs them money. Two, it's actually a national infrastructure liability, and they have KPIs from the government to have a certain amount of uptime, and you can only see when crises like this hit how critical this infrastructure is. So we looked at all sorts of information, so from things from engineering tickets to looking at what was in the equipment locker to start with, and crucially we looked at the smart meter energy data, and we were able to take that time series data set across these 22,000 towers and do some transforms like Fourier transforms or lags. And we were able to actually predict quite accurately just from that smart meter data when we combined it with what was in the actual masts themselves. And we did a live pilot, and we were able to, this was across 12 case sites over 6 months. Basically, they had engineers that would go to these sites anyway each year. And what we were saying was, let's send this engineer to this site on this day rather than that day. So it's not actually an additional cost there. And we improved the detection of these heat failures by over 1,400%. Which is really good because it's nice when you do a live POC and there's tangible ROI from it. Another project we've done, it's a massive one, and we were lucky enough to win an Innovate grant to do this, is logistics optimization for the NHS. And this is in the healthcare space, but pretty much what we did would apply to any large supply chain and manufacturing optimization and manufacturing kind of ecosystem. What we had was over 150 different blood products, all of which expired within 7 days. You have a sort of SLA essentially where you definitely can't not have the blood because people could actually die. It's extremely serious to get it wrong. And you've got the factor that not just the demand, but the supply is unpredictable because you don't know who's going to wander into a donor center. So we built a whole array of models in our platform to predict demand, supply at various different NHS trusts or donor centers. And then we fed this all into a big optimization model to say, all right, now that we know we know what our demand is going to be, we know what our supply is going to be, let's solve this to minimize loss. So the result of that, we did a side-by-side with the current system in NHS UK, and we were able to reduce the daily waste by 54%, reduce the ad hoc transport between hospitals by over 100%, and did that without reducing any of the actual supply to the end user, the patient. This was meant to actually be live already. You can probably guess why this AI-powered blood demand planning solution didn't go live last month, but we hope to do that later this year. And just to reiterate, this really applies to anything where you've got a demand, supply, you can only hold so much stock. So there's a huge scope for applying this in OEMs too, and we're actively looking at that with quick release. So it's quite an exciting area for us. So just to kind of wrap things up, like, what do you need to do if you think you're ready for AI? And this is a journey we've helped a number of companies on across loads of sectors, but I'd say the single most important thing is to get 3 people in the room, get the business stakeholder, the data stakeholder, and someone who understands data science. And then you can brainstorm potential POCs that are available in terms of the data. So, there's no friction to get that data, and which actually that are possible in terms of machine learning, but also that actually bring value to the business. then you'll have a big map of POCs and you can see, this is the one we should start with. And instead of just going through and doing a bunch of POCs, take that POC and try and take it to a pilot and try and actually get some return on it, instead of, we see a lot of companies just spend years building out partial kind of AI applications without actually getting it to the end user. And if you're not getting it to the end user, you're eventually going to run out of, well, you're not actually bringing any value into the business, and it makes it challenging to get access to data, because people that aren't in the AI group are wondering what the point is of them spending their time if you're not delivering value. And if you don't have the correct amount of data to actually do anything with AI, that's fine. You just need to think about what those POCs might be in the future, and that can sort of allow you to collect the right data going forwards and make sure that in 6 months' time, or in a year's time, or in a couple of weeks' time, we can use that data and actually start to build something valuable that can actually have some benefit to the company. So the question is your company ready to start the AI journey? Thanks.